Let's learn how to align geometries using Simcenter Testlab Neo so that we can use the Neo Modal correlation tool to compare a simulated model to a test model. The first thing I'm going to do is go to my file add-ins and make sure that both my geometry add-in is loaded in if I need to import geometry, but if that's already done, I need to make sure I have modal correlation selected. It costs 25 tokens, and once I've done that, I can come to the Modal tab. So the first thing I'm going to do is I'm going to select my working geometry and my reference geometry. Now my working geometry is usually the wireframe that I've performed in the real world and done my modal analysis on. So I'm going to right click on this and set working geometry. Now my reference geometry is what I've used for my simulation. So I'll come into my exhaust, right click, set reference geometry. We'll be testing an exhaust first. If I want to get my modes to correspond to them as well, I have to come into my mode set. On my test modes, I'm going to right click and set this as the working mode set because these are my real data that I did the processing on. My simulated mode set, I'm going to right click and set as reference. And one quick tell that my simulated mode set is indeed simulated is I can see that the first 6 modes are exactly at 0 Hertz, which we would expect for the rigid body modes to be at. So once those are selected, I can right click fit model to see my model. And we can see that there's about 20 nodes in my working geometry, but none of them have matched up. So what we can do is align them through a point approximation. And I think this is the most common and useful way we can align geometries. So what I'm going to do is I'm going to come down to the status control bar and I will click pick pairs. So I can click one pair and I'm going to try to zoom in and do my best to approximate where I think that node pairs to and click add node pair when I'm done. And I can do this over the course of the entire structure. I don't need to align every single node for this to work. I probably need to do, depending on the geometry, at least 4 or 5. Now I'm going to zoom out and do my best to select here and here. And when I click stop, my nodes haven't paired because one model is way out of tolerance than the other one. In this case, somebody accidentally made the simulation model in millimeters and we did our test reference in meters. So to correct that, I need to come up to the tolerance and set this to a much higher tolerance. And now I see that my nodes have paired. If for whatever reason I notice that one of these is off and I need to change it, if I'm not in the state selection, I can come in manually and delete and change nodes by just clicking in this chart. So it has my working nodes matched to my reference nodes. And it also gives me the transformation matrix that it's using to scale, align these geometries with one another. So now if I go to modal correlation, my MAC matrix will have automatically generated, and I can come in and click on my modes and see how they animate with respect to one another. Okay, let's go back and then show the other 2 ways we can do this. I'm going to set my tolerance back to 0.01 because that's what it ideally should be. Now we're just going to do it purely by proximity, and proximity uses a tolerance to show which nodes are closest to another set of nodes. So this method is used if you don't need to do a lot of scaling, your geometries are mostly the same and they're aligned mostly the same. So I'll come down and make sure I'm in by proximity, and this time I'm going to set my wireframe for my car. I'll set this as my working geometry, and I'm going to set my CAEs, my reference geometry, and I will right click fit model so I can just see them more easily. So you can see I've got these cars. Now automatically, based on my proximity tolerances, it's matched 100 out of 102 nodes. If I were to come down and switch this method to point ID, it drops to 0. Now we want them to map, so I'm going to come back to proximity. And if I played around with the tolerances, I'm sure I could actually probably get 102 out of 102 to match. So you can see the transformation matrix it's using is basically 0 because these are designed right on top of one another. In fact, if we wanted to see that, we can click the overlay geometry button. I can right click fit model and see that these are perfectly aligned. So if I went into modal correlation after I set my modes, I would get my MAC matrix. Now the last method is to use the point ID name. So the point ID name is the name of the physical nodes. I can turn those on really quick by just going to right-clicking deformed model, nodes, and names. So here's the name of all the individual nodes. Now because these node names do not match these node names, in fact I can double check that. One of them's called body 101 and some of the simulation modes are just numbers. These aren't going to align. So let's look at a case where we actually have the names that were specifically designed so that they matched up. We wanted to make it easy on ourselves. So I'm going to load this plane wireframe in, set as my working geometry, and I'm going to set the simulation model as my reference geometry. And here, because these are actually aligned by proximity, that method would work too, but I'm going to use the by point ID method. So by point ID is showing me that these individual names on the nodes here will match up with our CAE model. So if I go to my list button, I can see that the working nodes have matched to my reference nodes, and 54 of 54 nodes have matched up exactly. So now if I wanted to, I could go into modal correlation and set my working test mode and my reference CAE modes, and then I could get a MAC matrix, which I will do. So I'll come in here. These, once again, you can tell because they're all at 0, so these are my reference set, the set that I simulated, and this is the set that I actually performed my test on, so I'll set working modes, and I'll come into modal correlation, and now my MAC matrix has been generated, and I can click the modes that are the highest aligned by percentage. This is about 84% similar, so these mode shapes look pretty similar, whereas these off-diagonal ones that are in blue are not very similar at all, and I can see that when I click on these, that these shapes look exactly nothing alike. So that's how you align geometries in Neo to do modal correlation.